So, after 4 years of prompting, I finally decided to do something practical in the machine learning space. I do this with the sole intention to gain more intuition about the field, which I hope will help me navigate the scene that tech is and the direction that it is going forward. So, last year I attended a meetup for a company called Prime Intellect. Now, I don't have much interest in learning AI or machine learning or whatever, however many arms the AI field has. And the reason for that is that I don't know any math. And I was often demoralized by the idea that you need to understand mathematics to be doing machine learning, which turned out to be wrong. And now I believe that a lot of the machine learning engineers I see online, they don't do anything with mathematics necessarily. They're just using what other people who know mathematics figured out already. And this is also the case for software, right? A lot of the developers we see, me included, we use tools created by other people, we utilize them and we leverage what is already out there so that we can do our work. But anyhow, now at the time I did not understand a lot of the stuff that they were talking about, but what I understood was the stuff that they were talking about conceptually. And it felt good. I remember in the meetup they were talking about how they don't think that there will be one huge model that will be doing everything, but rather there would be a lot of small models specialized, like specialists models that would be fitted to do something very specific. And there would be a lot of those. This time I actually utilized their product to do something practical in the space, which was to fine-tune my own LoRA model, evaluate it against the base model with a concrete end goal to have something that I wanted to do for a while, which is a workforce analytics agent, which is basically a surveillance agent. The concepts I learned during this exercise that I created for myself are what a model is, what code architecture for a model is, weight sampling settings, tokenizer, the complete model experience, input, output, inference, hardness, kind of a cringe word I believe, hardness, then it turned out that it's not cringe because it makes sense, hardness, evaluations, what synthetic data is, reinforcement learning, hardness, rubric F1, precision and recall, overfitting, VLLM. The theory I went through was not something that I was expecting. I thought that it would have been a lot easier for me to understand the concepts, but I had to go through a lot of analogies to actually comprehend what I'm dealing with. So the first thing I did was to start chatting with Codex and ask it what a model is. Now, when it started explaining what a model was to me, it was using a lot of mathematical terms. So I stopped it and I said, look man, I'm coming from software engineering, I don't know anything about math, so let's go with a few analogies. This entire process took about 2 or 3 hours, which was kind of insane. In the beginning, I made the analogy with how you see, I like to deconstruct things. So I started with real life stuff and I was like, okay, so we are made of flesh and bones and those are made of something else and blah, blah, in the end it all comes down to atoms, right? Okay, so this is kind of like a computer, right? We have the computer as like the latest, the last stop, and the first stop is the bits. Those bits, they combine themselves into data structures eventually, and those data structures then pass from here to there. There are some processes happening and they all live in some environment which is our computer, and it utilizes some resources which are our CPU and GPU. Right, so the model is practically the world that we live in and its boundaries, what is possible. Then the weights are kind of our moral compass of what decision we are most likely to take due to our internal beliefs that were wired inside ourselves, like our political views and so on and so on. Then the tokenizer is this biological contract that allows us to comprehend language, to break it down in chunks. Like if I hear English, there is some process that's going to happen inside my brain that is going to break it down into chunks and I'm going to understand it. This is what the tokenizer is. Then the sampling settings are how likely I am to be let's say, more radical in my response or more grounded. These are the sampling settings. And there is something interesting about the sampling settings that I didn't know, is that if a company trains a model and it hosts the model, it can just restart, for example, the VLLM server with new sampling settings, and they don't have to train another model, which kind of may explain if there is some way to hack the sampling settings of Cloud Opus, for example. That would kind of make sense why it feels like it degrades over time. I don't know, just a theory. I don't know if this is how it actually works. Probably not. Then you have the input. I input something in the model, it does all of those processes, and then it outputs. So the input is kind of like something that invasively happens to me. Not necessarily invasively, but externally happens to me. Like my girlfriend come to kiss me, or someone is attacking me. And the context then is, when someone is attacking me, okay, I get the input, but then the context becomes, what is the weapon, what is the environment in which I'm being attacked, and so on. And the output then is my action to this. Like, do I attack back? Do I kiss my girlfriend back? I do, and so on and so on. And then the context is the working context. For example, is my capacity to momentarily remember some stuff. So So for the first practical thing that I do, I install the Prime CLI, then I initialize their basic, like the starter environment that they have, which is my env, and I go and look through the code. The code is not a lot, but I see that there is something there called a rubric, and the rubric it does not exist, so I can't run the code. And now I have to understand what a rubric is. Well, a rubric is a way to evaluate the output of a model and also set the rules by which it gets rewarded. So, okay, I have to create a rubric now. But first of all, before that, I have to understand what I'm going to be rewarding, what I'm going to be fine-tuning. And so, since I couldn't fully understand what I'm actually going to be doing, I asked the model, okay, look, what options do I have? And it goes with some more examples of what I can do, and I understand, okay, so basically I need to have an environment in which the model is going to be doing some stuff and some actions, and those actions need to be very clearly evaluatable. Okay, well, then let's create a pseudo basic terminal game, a text-based game, where the model will be inside a maze, for example, and it would have to find the shortest path to, let's say, the exit. And then the model would be able to do left, right, up, down, and that's it. And Codex was like, okay, yeah, that's perfect, let's do that. We do that. It generates some basic Python code for the game, and it creates a basic rubric that I can then run. So I execute the rubric, I see the correct output, the successful output in the terminal, and I then use the Prime TUI, the evals TUI. So I see that, I then look at what's happening, and conceptually I understand it. The model did some stuff. Those stuff that the model did were evaluated, and I rewarded it based on the metrics based on the logic that I put to evaluate it, and then it finished. Okay, that's nice. Then, for the second thing that I did, I was now getting into a more end goal-ish mindset. So I was now feeling very comfortable to fine-tune my first LoRA adapter, which then I understood that LoRA is actually a weight to apply additional weights to the weights of a model, so that the model will act in this new way that I have fine-tuned it to act in, without actually changing the weights, which is nice. So anyway, I was feeling comfortable to train my to fine tune my LoRa adapter now. So I go on and get a little bit more practical. So I ask colleagues, hey, I want to create this workforce analytic agent, right? It's like, yeah. You want to do that, cool. And I say, okay, but help me understand a little bit, why exactly am I doing all this fine tuning if the models from the big labs are good enough so they can present a pretty good number of outputs most of the time. And Codex was like, well, this is exactly the reason. When you want something specific, you are getting when you want something specific and you want to get some output from the models are non-deterministic. You are not getting the same output every time. And when you want to have a production grade system, well, what you want is to increase the chance that the output the model is going to give you is the output that you need. So practically, if you have some very specific task and you know that you're able to evaluate the actions through which you're going to achieve this task, it is good to fine-tune or train a model to do this thing specifically. And now I kind of understand what Prime Intellect meant at this meetup, that there would be a lot of small agents instead of one big agent that could do anything. And it is precisely this accuracy in the outputs that they meant, I guess. So I go with the second part of my practice and I say, right, okay, let's go and create the software part of it all first. Let's create a background service that would record my keystrokes, the active window that I'm on, the tab names in Chrome, and let's put all of this into a metrics file for now. Let's not use a database, let's use a file. And I create this, so I end up with this thing here. And with this, I'm like, okay, cool. Well, let's then evaluate how we are going to be turning this into a fine-tuned LoRa, right? And colleagues are like, okay, let's do that. But for that, we'll need a lot more data. And I'm like, okay, cool. Well, how do we achieve this? Well, synthetic data. Right, we can just generate it. And colleagues like, yeah, exactly. Synthetic data is something that labs are doing quite often. And I'm like, okay. And so I do it, and I generate quite a big data set for this. And I ask colleagues to create some evaluations for it. And it seems like we are successfully able to reward a model by asking questions like, why was this session marked low productivity, or which of the following entries most supports the saying that this specific employee was not productive in that day, or what exactly was this employee doing in the application messages for that long of a time. So that worked, and I pushed the model. I actually started my first fine-tuning session, and then I was looking at the graph that would go up, and I was happy about it. After some time, however, I screenshotted my graph and sent it to Codex and asked it, okay, what is going on? It fluctuates quite a lot. What is happening? Codex is like, well, the problem here is that the base model is just, it's good enough for us and the way that we did this. And so we can't reward it properly because the accuracy by which it responds is often perfect, like 100% accuracy. So we have to make this a little bit harder. And I ask, okay, how do we do this? Well, then Codex introduced me to the concept of F1 scores, which F1 is basically the mean between precision and recall, which means that I am using now a evaluation metric to fine-tune the model, basically get this score that the F1 is, and use this to reward the model if it does good or not, to basically calculate how good the response is, which works with something called gold IDs or gold labels, which we are using in this metric to compare the response to the actual correct values of the model. So I do this, and then the graph starts looking a lot better. And in the end, I get a model that I get a fine-tuned LoRa that I can attach to a model. And this is where the fourth part comes, which is hosting my models. And for this, I initially tried to do this on my Kubernetes cluster. Unfortunately, DigitalOcean was not providing the capability to add a GPU node to the region that my cluster was living in, which ended up being actually good because I would have probably forgotten it and paid a lot of money. So then I had two other choices. I could go for RunPod or I could go for Modal. And RunPod was my initial direction that I wanted to go, but then it turned out that it's a lot harder to, well, not harder, but it kind of resembles self-hosting. Like you have a lot more control over the stuff that you're going to be deploying, and I was like, I don't want to deal with any of that, so I just went with Modal. With Modal, I created a file called modal.app or something like that, which was really close to what a Docker file is basically, but instead of being declarative, it was like programmatic, which was like, cool, I understand this quite well. I created the app, I deployed the container, and then I tried to run to inference my model, which took about 4 minutes. And I was like, okay, why is this taking 4 minutes? And then it turned out that the containers with my configuration that I did were code booting every time I would make a request. So I had to deal with this by creating a ping script and also increasing the threshold by which the container is going to stop and then have to boot again. The ping script would ping every 5 minutes. That would keep the container alive. So then I hosted my model, I hosted my LoRa patched model as well, and I started doing evaluations against this. So the first thing I do is I create a script to evaluate them with a couple runs. It does that and it gives a very clear proof that my LoRa patched model is better. The base model precision and recall would be something like 0.25 and my LoRa patched model would have 0.5, which is like 2 times more than what the base model allows. And I'm quite happy with this, but then I ask Codex, well, we trained it with this data and now we are evaluating with the same data that we trained. It is kind of obvious that the LoRa model would be giving better results, right? So it says, yeah, well, let's regenerate the data. We regenerate the data, the results are kind of the same, then I'm still not happy and I ask, okay, well, let's do something else. Let's regenerate the data again, but introduce fake values and also introduce false positives. And we do that as well. And the result is once again 0.22 or something for the base model and 0.5 again for the LoRa model, which is again 2 times better than the base model. Then I also created a web UI so that I can see all of this in my browser, like simulate a real environment in which I'm using this surveillance agent, but that did not turn out well. And I remember that I'm doing some learning, so I don't have to do anything production ready right now. Yeah, and with this, I'm basically done with my exercise. I learned a lot. I learned what a model is, the entire package that a model contains, which is the model, the code architecture, the weight, the sampling settings, the tokenizer, the inputs, the outputs, how those work, what context is, what working context is. Then I learned what reinforcement learning is. Then there turned out to be something called reinforcement learning through human something.
Hello there.
From human feedback. Why is this called then? Oh, human feedback. Anyway, yeah, I learned what reinforcement learning is, I learned what an evaluation is, I learned what F1 is, what goal ID is. This is just one technique by which this is being used. I got to understand a little bit more about Prime Intellect and what they do, and I also understood that I don't have any interest in doing anything machine learning related, because the job itself, it feels very slow, you know. You have to min-max a lot of stuff, and I personally don't feel like min-maxing is something I identify myself with. I don't find any fun in it, in min-maxing. I am a lot more chaotic in my work. I like having 10 different panes in Tmux or like 4 different tabs and doing a lot of stuff, context switch a lot, but And yeah, this kind of doesn't happen in machine learning. You have to be very precise in what you want, and you have to have a very clear path, assumed path to how to get there. And I just don't think that this is something with me. What I think is for me though is harvesting the big models and the models that those companies or machine learning engineers are producing and creating the stuff that I like, which is creating my, for example, my own text editor, then prompting the model to create the entire directory structure for a project, then paste some Terraform files and initialize the Terraform, ask it, go read these docs while it is doing that. I'm gonna go and look something in my cluster and so on and so on. So yeah, it was a nice exercise. I thought that it would end in a day. It took 5 days, and the greatest thing that came of this is that I'm actually making this video right now and the blog post that I wrote, because you know, I have written about this numerous times, that the models kind of stripped me of any purpose, because what I was attempting to do before that, which was to get really good in software, was kind of stripped away from me, because now everyone else is able to do that same thing at the cost of $99 a month. And its name is Cloud Code, right? Well, I was wrong with this, because, well, practically this is just human evolution, right? And so what is my purpose now? Well, since this is happening, and since I have this great power in my terminal, well, I can use it to do whatever I want, right? Something like this, for example. This would have taken me months probably to learn in the past, but now I could do it in a few days. And I also created, as I said, my Markdown editor. I created a lot of applications during that time, and all of those things that I'm doing, they would have taken me a lot of months, and I would have probably given up, as I did before the LLMs, on a lot of my side projects. So the best thing that came out of this exercise was me understanding that I can do whatever I want, and I can make videos like this and write blog posts about that. And when I do something, when I finish a blog post, when I finish a video, I feel satisfied because I did something and I did it until the end. Like, yeah, the end, the presumed end is something that I set, but I reach it, right? I reach the ending of my article and I reach the ending of my video, so this gives me purpose, and this makes me feel happy, and this makes me look forward to the next learning session or the next project or the next whatever that I'm going to create. So what I think I'm trying to say is that the terminal agents and the LLMs, even though they stripped me of my previous understanding of what my purpose is, they gave me a new purpose, which is to create. And I'm happy for that. So yeah, this was my first video about something that I did. I will put in some time editing it, I hope. And if you wanna follow along for other such videos, you can. This is cringe as fuck.